that thing working? Or? Is that better? So today I'm going to talk about Zipline, which is the open source backtester you can use for algorithmic trading research written in Python. And I just want to introduce myself real quick. I studied computer science at the University in Tübingen, which is in Germany, as you might have guessed, where I also work at the Max Planck Institute for Biological Cybernetics. And currently I am pursuing a PhD at Brown University down in Providence. And there we're studying the brain and doing computational neuroscience at different levels, and also a lot of Bayesian statistical modeling. Then since last year I started to work part-time at Quantopian, and there we're building a web platform where you can go onto and get an IDE to develop training algorithms, and then we provide data and you can test it on historical data to see how well the algorithm did. And Zipline actually, which I'm going to talk more about, is the backtesting engine that's running at the core and actually doing the simulation, which we open sourced. And I'm also, so at first I'm going to talk about Zipline and what that can do standalone, and then I'm going to do a demo of Quantopian and see how that basically leverages the power and it makes the access easier. So first of all, what is algorithmic trading and what is backtesting? So algorithmic trading in the broad sense is just automating the trading process, the investment process in the stock market. So traditionally, people just have been doing that based on hunches, but obviously it's good to have a cold approach and not let emotions guide you. So that's why those are very famous methods to just let the computer do those decisions of which stock to buy and when. And to develop that strategy, you really want something robust, right? You don't just want to use the first thing that pops into your head. You might have bugs or whatever. So that's why you really want to be sure to test that strategy before. And sort of one approach is to just test it on historical data and see how well would this approach have been if it was the year 92 or whatever. And then really optimize that strategy during backtesting, and then finally, once you're satisfied with that, go live. And there are a lot of problems associated with doing that so that you don't fool yourself, as with any modeling, I guess. And we'll talk about some of those. But in general, the way backtesting works is you have your database on something, yeah. So you have just the historical stock data, and that contains basically the date times, and for each time point you have the price information and volume and other indicators for a given security. And then you stream those historical results through your trading algorithm, which is whatever you came up with, from very simple to very complex, and that often applies some transformations such as the moving average, and then based on that and the price information makes a trading decision, places an order, and then the backtesting engine essentially takes that order, sees can it get executed, and updates your portfolio and tells you basically how well the state is. And then in the end you want to analyze how well that strategy actually does, so you do some performance and risk analysis, and then basically reiterate over that process a lot of times. So, and certainly what is a critical feature is that that whole process should be really as close as possible to the real thing, that if you go live with that strategy, that you don't not unpleasantly surprised. So what about existing solutions? So primarily those are proprietary solutions, which are very costly and closed source. Also, they haven't really attracted much of a community. And actually, most backtesters, I think, are not even available, because basically a lot of people, a lot of serious quants just write their own. We talked to one guy who works at hedge fund, and he says, yeah, like basically every new guy that's coming in is writing his own backtester to get going, and that just seems like a lot of resources wasted. And then certainly, and you can, and a lot of people do, financial analysis and some sort of group backtesting using Excel and MATLAB. And you can sort of get some way with that, but a lot of the complexities, it's very easy to miss a lot of the complexities that actually come into play, such as the transaction costs involved, or actually, can you buy a stock at a certain time point? I mean, sometimes no one will be selling it to you, right? So over those details, it's really easy to brush over. Or also that if you place a big order, that will impact the price, right? So you have to somehow simulate the impact of your own orders as well to try to have an accurate representation of actual trading. So certainly, so there's the Python meetup. So obviously, we want to find a Pythonic solution to that. And what I really like about Python is that it has that really rich ecosystem where for lots of different domains, some of them only listed here, there are really good software packages that people can just use. However, for quantitative finance, there is not that much available, but with Zipline, we're hoping to basically fill that gap. So what is Zipline? So as I alluded to, it's a trading simulator that allows you to backtest your financial trading algorithms. It's totally written in Python. It's released under Apache license. The whole system is inherently event-driven. So that means that we're basically pretending that the trade events that we get from our historical data set are coming in real time, and then we're streaming those through our system, and you can only access data up to a certain time point to avoid look-ahead bias, so that you don't act on information that will only happen in the future, which would normally not be available to you. We also include a lot of the normal financial transforms or indicators that people look at, such as the moving average, the Sharpe ratio, alpha, beta, to really make it easy to just get right to the algorithm writing and not be concerned with a whole lot of extra legwork. And finally, this is also the software that's used on Quantopian.com. And so why did we open source that? And one reason is certainly that we are using a lot of open source in our own system, so just contributing back to the community. But also, obviously, we want to give our users the best open source, the best backtester possible. So we're hoping, or we are, looking for user contributions. And yeah, finally, this is the address where you can download it, do changes, give us a pull request. We'll be happy to look at it. Another thing which I find critical and which we definitely thought a lot about while designing the system is interoperability with that whole rich Python ecosystem. And one of them I want to highlight is pandas, which we use for data inputting and outputting, and is in general a really good tool for everything data mangling and data series management. So if you don't know that, definitely check it out. So before looking at it in more detail, I wanted to give you a high-level overview of the architecture of the system. So the trade source is basically the database or the CSV file, whatever, that is emitting the information of price and volume and all the information that you have. And each single event is then passed on to the transform layer, where different transforms are being applied, such as, and these are just examples that are user-defined, such as the moving average, volume-weighted average price, or we can do linear regressions, which is basically, so these moving averages are more called what is called technical indicators, and mainly looking at only one single security at a time. But now people are looking at really large sets and trying to play them against each other. And for such techniques, linear regression and other machine learning techniques play a bigger role. So then after you apply all these transforms to the incoming information, you pass all that information on to the user algorithm, which is where you can specify the code to then, based on those inputs, place orders. And then those orders are passed on to the transaction simulator, which sees, well, can you execute that, and calculates the price you would be able to execute it, and all that. So let's look at some code. So for those who don't know, this is the IRhythm notebook, which is essentially just an IRhythm shell living and running inside the browser. And it's really nice for presentations or showing analysis to other people. And basically, you can intersperse text with Python code, which you can actually execute. So in the background, it's running an actual Python interpreter. Is this large enough to see? So first of all, we need to import our basic packages, which we're going to use, and certainly we're going to use pandas, which we'll use for the inputting and outputting, as I mentioned earlier. We're going to use NumPy for the array support, and matplotlib for plotting. And then the main entry points to Zipline are going to be trading algorithm, which is the base class, and that will import from Zipline.algorithm, and then we need to get some data. So for that, there is a function that scrapes data from Yahoo, Yahoo Finance, and gives us something to play with. So basically, this is the code to load it from Yahoo, but since I can't always rely on
put new lines for the semicolons? Well, that's actually that's all counted out. Okay.
That's counted out, yeah. So so now it's basically going onto Yahoo and extracting Apple, Pepsi, and Coca-Cola. Actually, here we'll only use Apple. So, and this function then returns a pandas data frame. And that looks as follows. So the columns are the different securities or stocks that we extracted. And then for each row, there is a date string, which is the index. And then we just have the price information. So just very simple data table. And then obviously we have very simple analyses, such as just plot the price of Apple over time. And so in our case, we'll just look from 93 to 2002. So to give you a sense of the syntax, I'm going to start with the most simple algorithm possible, and that algorithm will just buy Apple each chance it gets. And so the basic thing, which gives you all the functionality, is trading algorithm, which is the base class. So here we just inherit from this base class, and that will give us all the boilerplate stuff to actually set up and run our simulation. And then we'll have to overload the handle data method, and that receives the data argument. And critically, data will not be like the whole data frame that we just looked at, but it will actually be each single row of that. So basically, the functionality of Zipline will chop this data up and give us each line at a time, and then at each line we can decide what we want to do with that, right? So in this case, actually, we don't even look at the data, but we just call the order method of our inherited base class and tell it which stock we want to buy, in this case, Apple, and how many shares. So we'll just buy one share. So each day we'll be buying one share with this strategy. And then we'll instantiate the object, the class, and call the run method on that. And the run method receives a data frame, and that is exactly what we loaded, so that will be the data that is streamed through, right? So up until here, we didn't even specify any data, so that we detached essentially the logic from the data, because you might want to use a different data set or whatnot. So this basically then starts the simulation and goes through the whole history and just sees and plays the whole thing through, and returns us another data frame. And that data frame, which I call results by Apple here, has a bunch of different columns. Also for each day, there is now the performance essentially of our algorithm. So we want to know how well did our algorithm do, right? And that has cumulative capital used. So since we buy one each day, this will just keep on increasing. How much cash? By default, we start with, so there's 100,000. And since we're buying, our cash amount will go down continuously, and all kinds of other things you might want to look at, such as our portfolio value. So what is the worth of everything we own? And as you can see, we start out with 100,000 because that's what we started out with, and as we just keep on buying Apple, obviously we'll be at the whim of the price of the Apple stock. And so once this, but actually, since we're keeping on buying more, that effect will be exaggerated, right? So this looks kind of similar to this above, but the longer it goes, the more excessive will the price swings in the Apple stock affect our portfolio. So we're doing pretty well over here, and then to lose it all later. And you could argue that certainly this is not a very adaptive strategy, right?
Since it ignores the one piece of data it had, yeah.
Right. I mean, depending on when you started, it might be a very good strategy, actually. But, yes?
The other thing that may be going on is that there were some stock splits at that time. That your price here is not, you'll move through in our adjustment.
Yeah. So the comment was that the data actually might have funny things in it, like a split. That's actually a really good point. And something which we'll also see later, but since you mentioned it, it's really difficult to get good data. And if you just do that, you explore a wider range, you run into a lot of problems because Yahoo data can be very inconsistent, and then there are weird price jumps which are not actually present. So that is definitely a major problem when you want to do that, if you own it. But we'll come back to that point. Thank you. So, yes, so certainly it would be nice if for that strategy we would be realizing that there was this upward trend and then enter the position. But once we see that it's crashing down, assuming that that is real, that we just exit our positions again, right? That would be the sensible thing to do. So the next example will be doing just that. And essentially, so I'm going to show you the behavior of the algorithm before I actually show you the algorithm to get an intuition for what it's actually doing. And the idea is to compute two moving averages. And moving averages, which are, I guess, the blue and the green line here, the smooth lines, are really nice because they basically smooth the history and also give you a sense of the underlying trend of the data, right? So definitely just looking at the price is very noisy, and you can't really see like it's going up or down, and the moving average gives you a better sense of that. And the longer the window you're going to compute the moving average over, the more stable or the more long-term that will be. So in this case, we're going to use two moving averages, one that is short and will react to more short-term effects, and one that is long and will capture the underlying long-term trends. So then we can assume that if the short moving average crosses the long moving average, that there's an upward movement in the stock, and then we want to buy. And conversely, if the short moving average then again comes down, as it does here, then we assume that there's a downward motion and we want to exit the positions. And so that is what that algorithm does. And these triangles here actually, so this is a buy order that we placed, and this is a sell order that we placed. And now we're going to look at the underlying logic and what you have to do to implement that in Zipline. So before we just did one thing, right? But now we actually have to use that moving average, and we have to include that in the hierarchy, if you remember that architecture picture I showed you earlier. And to do that, we have to add that transform in the initialize method. That's another method that you overload. And in contrast to the handle data method, this method is going to get called once before the simulation starts, right? So that's what's called initialize. And you can give it whatever arguments or keyword arguments you like. And then here we call the local add transform method. And that receives a class as the first argument. And that class is the moving average, which we import from Zipline transforms. And that has different transforms like standard deviations, and we're working on adding many more to those. So we pass it that class, we give it a name. In this case, this will be our short moving average, that's what we call it. We tell it which field to operate on. You can do moving average over price or volume or whatnot. And then we have to tell how long the trading window is supposed to be that you want to evaluate the moving, or in this case the moving average, but in general the transform over. So this we'll do over 200 days. And then we also add a long moving average with a 400-day window. And then we'll need a state variable to keep track of whether we already bought Apple. We don't want to keep on buying Apple once it crossed, right? We just exit the position once, and then we'll exit once again. And this is just a nice convenience that we can say to record certain variables. So this will just be a list of strings, and basically Zipline will expect that you have variables or attributes with those names inside of your trading algorithm. And then what it will do is, at each iteration your algorithm is going through, it will record the state of those variables, and then later on you can access them. So it's just a way to accumulate the variables that you're computing while it's going on. So that was essentially what I plotted below with the moving average, right? So in the handle data method now, which, as you recall, called consecutively for each incoming trade event, we'll just extract the moving average of of the incoming data. And in this case, so before we didn't even look at the data, we just kept on buying. But this is actually a dictionary, and that has certain keys. And the keys are the securities that are available to you, which you provide with passing the data frame. And inside of that dictionary are different attributes such as the price or also the transformations that you added. So in this case, there is the short moving average, which we told Zipline about over here. So that is where we define the name. And then the transform layer will tag on that field, place it into the data frame, the data event thing that's coming in here, and then here we can just pick it up. And we have to tell which field it's supposed to operate on, price. So this will be the state variable, and after each run through, this will be recorded and saved, and then later on returned. And then we'll just have to, we'll just initialize buy and sell as false, so remember when we bought and sold. And now here we just place that logic that I explained in words before, right? So once the short moving average crosses or is larger than the long moving average, and we have not yet bought the stock, then we want to order 100 shares of Apple and set our variable to true and say that we bought, and vice versa. So just to give a sense of how fast that is. So again, then here we'll instantiate our algorithm and again pass it the same data we used before. Okay. And then the results data frame that we receive has, again, the things we already looked at, but now also actually includes the state variables that we told it to record before. So there's the buy variable, and then there is the short moving average and those kind of things. And then there's some code which is just basic matplotlib syntax. We can just create those plots. And as you can see, the algorithm in this constructed case works quite well. So we enter the position here, so that's why our portfolio value will start to fluctuate along with the price of the stock that is now included in our portfolio until we sell it. And then here we successfully detect that upward motion and enter the position and are able to exit before it came crushing down. Yes, please.
Do you happen to know the day that Steve Jobs rejoined Apple?
I don't know, but it's pretty striking. But yeah, I wouldn't be surprised if that was not, there was something going on here that actually is not the actual price. And also just as a caveat, like these strategies, I mean, dual moving average has been around since the 50s, but like I guess a serious quant wouldn't be really using that, and I doubt it'll be a profitable strategy if you start doing that now. So I'm not giving investment advice, but it's just illustrative to look at it, and also the time scales. I mean, normally I guess you would do that on a much shorter time scale, but it just gives you a good intuition for what this kind of algorithms are trying to accomplish. So in the last example, I want to, yeah.
So I had a quick question. So how do you decide the window length for moving average? Because that would be an important factor that decides how fast.
Yeah. Yeah, that's an excellent question. So the question was, how do you decide on the window length, right? So here I just fixed 200 and 400, but maybe 200 and 380 would be working much better. So that is essentially the question, how do you optimize a trading algorithm? And that is a problem that does not only come up in quantitative finance, obviously, but in every scientific field where you try to fit a model and optimize its parameters to explain or maximize some objective function, in this case, profit. And you can use basically the whole optimization machinery that has been developed, such as some gradient descent algorithm or what have you, to basically run that. And so currently Zipline doesn't support that out of the box. Then I can just say, okay, optimize that, but it's something that we're thinking a lot about and actively exploring. It's not easy because you don't really know what the space looks like that you're optimizing. But yeah, it's an important topic. So yeah, if you have more input on that, I'll be able to chat later about that. So in the last example, I want to show you something which we call the batch transform, and that is essentially providing functionality to write your own transform, right? So before we just used the moving average, but obviously you might want to come up with your own transformation, and the batch transform is something that allows you to do that with minimal overhead. And so we import that as well from transforms. And also we'll use stats models, which is another Python package for which includes all kinds of statistical models like ordinary squares and what have you. And essentially here in this algorithm, just to give you the gist of what it's trying to do, we'll be doing something very similar to before. We again want to find trends in the data and then act upon those. And instead of doing the moving average, we'll just fit a regression line to the last, in this case, I guess, the last 50 days. We'll just try to see if there's an upwards trend, then our regression line will be upwards sloped, and if it's a downward trend in general, then it will be downward sloped. So obviously then we'll have to compute the regression over and over again over this moving window of length of 50 days, right? So the way to do that is with the batch transform, and you basically define a function that you then decorate with this batch transform. And that is essentially what adds the functionality to this function and adds the capability so that it will be called repeatedly and that it will always have the correct data in the moving window. So you basically code the interface as if it just would be a fixed data frame that you would be receiving, but actually it's going to be a continuously updated one. So it basically transforms everything into a moving window transform.
Why is it that batch transform? Does batch transform automatically parameterize itself, or how does it know what the windows are?
So the windows we have to parameterize everything. So it's just a function.
But this decorator.
So yes.
Doesn't know what it's operating on.
That's true.
I'm just wondering how you do that.
We'll have to specify that. So this is basically only the specification, but then you have to parameterize it once you actually want to use it.
Oh, so the extra parameters
defined later on. So this is again the idea of separating the parameterization from the data we want from the actual code. I mean, maybe I want to just write that once and then just send you that transform that I did, right? But you might want to use it over a different window length. So then you just, once you actually instantiate that, then you parameterize it. And that's what you'll see here in a second. So you program that as you would if you just received a data frame of unknown length and you actually don't even have to assume that it's going to be continuously updated. And contrary to before, this is not receiving like only a single event, right? Like the handle data, but it's now receiving the aggregate data of whatever we specified, how long that window is supposed to be. So it's going to be DataFrame. Actually, it's going to be data panel but let's stick to DataFrame for simplicity, that has the columns be the different securities that you have, and the rows be the time, and then you have the price information in there. And it's actually not two-dimensional, but three-dimensional, because it's not only price information, but it's also volume, so that's why it stacks into the third dimension. So in this case, we now want to estimate the regression for only the Apple stock. So we'll extract the price from that. So this is just normal pandas syntax, where you say, okay, I want to get the price of Apple, and then values just returns the underlying NumPy array, which we'll have to do to pass it on to stats models. That's just a technicality. Then we create an X variable, which is be 1 to n, to represent the input scale, and our prices will be the y-axis. And then we also have to add a constant to estimate an intercept. That's just, I guess, normal linear regression, if you're familiar with that. And stats models requires that. So this is maybe one thick line, but essentially this creates OLS, ordinary least squares model, which expects the Y data, the prices, and X. So, and then this model actually won't do anything. It'll just create the model. We then have to call the fit method, and that will actually estimate the regression coefficients. And then we can access the params of that, and that will be the slope and the intercept. Actually, the other way around, the intercept and the slope. So that is what so that function will just return intercept and slope once it's called. Then in the initialize method, we now have to actually instantiate that, and that's also where we'll have to parameterize it. So here is now basically the function, but it's not, we're not passing it the arguments of the actual function, of the underlying function, right? So we're not actually calling the function, we're just instantiating the class that it became by decorating it with a batch transform. So this is a richer data structure than it looks like, right? And refresh period is a parameter that specifies how often do you want to update that transform, how often do you want to recompute that. You want to, in this case, we want to recompute that daily, but if it's a very costly computation, which can take a very long time, we might want to only recompute that every 10 days, say. Or maybe we want to, if you're running with not daily data, but hourly data or minutely data, then like that really blows up easily. So it's nice to be able to control that. And then certainly we also have to again specify the window length and the field we operate on.
And the units on those are just data points?
Say that
The
again?
units are data points?
Of period and window length?
Unit of those numbers?
Which
Yeah, so this is days, actually.
But it's days because it was days coming in as your data is days.
So in this case, it's restricted to always mean days. So if you, and that is something which we haven't quite solved because it's a technical argument, but it's a much different story if you then actually want to specify, okay, I want the last 10 minutes or something, and then there's like you want the first hour of the day or something, and then the last 10 minutes. So that's why by default it's always days. And if you run in minute mode, then it will be 10 days worth of minute data. So it'll always be the same time scale, but there are ways to also specify basically around 3 hours and 30 minutes, but then it'll work differently. So this will now basically just register this transform and parameterize it. And then again, we'll need those state variables. In this case, we want to remember the intercept and the slope that we estimated. So just initialize those. And here, again, I'm going to tell Zipline which variables to record. So that'll be slope, because that's what we plot later, and when we place the by and when we place the cell order. So now in the handle data method, I'll just initialize those to false as above, and now I'm doing the call to the OLS transform. So currently, you still have to pass on the event frame to the transform. And essentially what that will do is not directly call this, but just aggregate a window. So each call, you just record the event until you finally hit the right length and you have 50 days worth of data in your window. And then it'll call this function with aggregate data. So each call of these will not actually result in evaluation of that, but it will automatically wait until the window is filled up. So that is also, I guess, the convenience of using the batch transform rather than doing it yourself.
So you're saying that the OLS transform is only updated every 50 days? That function's only called every 50 days?
Not quite. It's called after the first 50 days have been passed, and then every day with the updated data. But for example, you would be right if I set this to 50. Then it'd be the first 50 days, and then every 50 days again with the most recent 50 days.
So how are you going to get like on a daily, on an hourly basis for a given day?
Oh, am I going to get that?
No, if you have the data, how would you change the parameter?
So if you want to operate on still on days, but you have hourly data underneath, then like you just get more a larger data frame that'll have hours, right? So then you wouldn't have to change it. If, however, you want to say I want 5 hours, then you'd have to use different parameters. So and I think that is like you can specify dt equals, and then you give it a datetime object of. But then you also have to have another argument which says market aware.
Time delta.
Time delta is.
I meant the time delta.
Oh, I see. Oh, you get the gist. So that's essentially how you would do that.
And that exact part of how to get those windows is still some correction. Like that is one of our open questions of how to define that interface better.
Yeah.
So we encourage help.
Yeah. So yeah, for the days it's working as expected, but for the other one it's not working quite. Yeah, we haven't solved that yet. So I stopped at this not basically calling the function I defined above for the first 50 days. So what is it doing instead, right? And actually, if it's not computing anything, or rather, if the window is not full and it doesn't have any value, then it just returns none. So that's why we have to check whether what it returned is none. And in that case, we'll just bail and wait for the next event to trickle in, which will then again add to the window. And if the window isn't full, then it'll return none. So we'll just loop over the first 50 days without actually doing anything and just filling up that window. And then once we actually do not get none anymore, then we'll get the return values. So then actually it's going to call this function over here, and it'll compute the inner regression and return the parameters. And what's that?
The NP.
NP?
The LS transform.
Oh, that's NumPy. So that'll just return so then we unpack those values to be intercept and slope. And if the slope is larger than some randomly picked value, we'll buy. And in the other case, if it's a downward slope, we have a negative correlation coefficient, or actually slope, we'll sell. And again, those are parameters that you'll have to either hand tune or optimize in some way. And so if you run that, this will be slower than the one before, and plot the results. So I just played around with that. It's actually not working that well, which isn't surprising because linear regression, we're getting pretty hammered. And actually here we also go bankrupt. Borrow money from friends. And you can see why, sort of, because, so this is now in the third plot displaying the slope over time. So we're continuously recomputing the slope, right? And here in the first time it's just 0, where the window wasn't full yet. And then it's actually fluctuating pretty wildly. And even here, actually, when it would appear that there is like a good upwards trend, we're not really picking that up. And to show me that one of the big known problems of like just doing ordinary least squares is that it's very prone to outliers and noise. So having one data point that like doesn't really fit the regression line will completely shift that. So that's why this is really not a good thing to do, but it's simple. So before we had that question of the data, and as I said then, it's a real pain actually to get good data. You can scrape daily data from Yahoo, but the quality is pretty minor, and that is one of the big benefits of that we provide with Pointopian, where we actually went through a lot of pain to really clean up data and provide you with basically 10 years of minute trade data. So it's not a daily, it's minute, it's clean. And also it has something which is critical. It also has stocks of companies which are not traded anymore because they went under. Because if you don't have those in your data set, then you get basically what is called survivorship bias. You only trade on those that survived and not assume that it's possible for a stock to actually crash and just not exist anymore. So that's what we provide at Pointopian. So you just go to the main website on pointopian.com. You get to that screen, which is our forum, where you can ask questions and also actually post your own algorithm. So you can, we're really trying to create a community of people interested in quantitative finance, from very beginners to more advanced people, and have them help each other out and learn. And also exchange the ideas by posting an algorithm. So for example, you could click on that and then you see some description of what the guy did and the performance of the algorithm, what kind of risk metrics, the alpha, the beta, the source code, and obviously, so by default, everything you do on there is private, and no one's be able to see that. But if you want, you can share it with other ones. Yes?
Go back to that graph. You were fiddling with it. What is that?
So that is basically just an indicator. So if you mouse over that, you'll see like the value over here of like the current cumulative returns.
But that's an integration between the output of your modeler and your website presenting it on your forum, right?
Sorry, say that again?
You're working the website, and you've got a widget in the web page, and it's working on data that came from that guy's run of the model.
I think he likes it.
Exactly.
Yeah, right. Yeah.
The models are run on the server.
Right.
Right, But
And then
that guy's model.
Yeah. So what happened essentially is, so that guy, it's Michael Abbott, and he went on the website, created his algorithm, and then he ran the backtest as we did before with Zipline, and then we store those results in a database, and if he decides to open up his algorithm, then he'll post the algorithm and the results associated with that. So that's what I'm interacting with, for example. And also what I think is really, oh, and just one thing up front, the website is free, right? So you can just sign up and play around with the data. We don't charge for the data or the computing, so it's all in the cloud. What I think is really neat, and which users do a lot of, is to then clone that algorithm. So say I look at it and have some ideas for improvement. Then I would clone it, and the number next to that, the 42 actually, that if you caught that, was 42 people already cloned that algorithm. And so this is now the interface, the IDE you can write your Python code in to specify your trading strategy. That is very similar to the interface I showed you before. It has also the initialize and the handle data, but we actually do some niceties to make it even simpler to write your own algorithm. So you don't have to inherit from a class. You have like auto completion. So let's say we want the data price of Apple. So then we can just look up in the database what the SID. So internally we operate with just identifier string, but we can look it up from what that ID is from our database, and it will auto-complete that. And then we could look at the height or the moving average, and you also don't have to register the transform, it will be automatically registered for you. So we'll just do a lot of those things to make it really easy to get going with that. And actually I'm going to switch to another algorithm which I just showed you before, so that also has the batch transform. And actually here you also can specify the parameters directly at the where you specify the batch transform. And as you can see, the code looks really similar. So, and you can also, this might be too small, right? You can also import stats models. So we also include all kinds of different libraries like scikit-learn if you want to play around with fancy machine learning methods to figure out good trading strategies. And then finally, if you're satisfied with that, you can save it and click on Build Algorithm. And we're very big fans of instant feedback. So as soon as you just build and validate that algorithm, you just like stream it through in real time on Amazon EC2 in the background. And basically the data will be, which is on our database, will be streamed through your algorithm running in the cloud, and then you'll just get the results as the algorithm is running displayed in the browser. And you can see how well you did. And critically, so that is now daily data, but you can also do the same in minute data. And as you can see, you can just also choose a whole date range. So you don't have to worry about like where do we get the data from. It's right there. And as I said, you can also just choose minute data. Obviously, that would be much slower. And once you're satisfied, you might want to run a full backtest. And that essentially also gives you like log output to see what it's doing. The red line actually is the benchmark data, so it's the global trend of the market to compare how well you're doing in comparison to what the overall market was doing. And you see the alpha and beta, those and all the kind of risk, those are just risk metrics that you might want to look at. And so once you're satisfied with that algorithm and you want to maybe get some feedback, you can click on share results and then do a post on that. So yeah, that's, I think, that. So to wrap up, I showed you that Zipline enables fast exploration of algorithmic trading strategies. If you really want like tight control, I think it's a really decent toolkit. However, at Quantopian, we really want to build a community around algorithmic trading. We give you historical data that we update daily, so you can always test your strategy on like the last day. And we provide also the whole infrastructure to actually run those. And we do all that free of charge, so you're more than welcome to check it out and create an account or just be anonymous. And just some upcoming features. One which we're heavily working on is actually live trading, that you then be able to, once you've backtested your strategy sufficiently, to then just go live and actually invest with real money in the stock market.
The first step there is we're going to work on paper trading.
Right.
It's like simulating running against the market in real time.
Yeah. Yeah. So the intermediate step would be, before you actually play with your own money, you just simulate what it would do in real time, and then the final step would be to actually invest. So thanks for your attention, and I'm happy to take questions.
Talk a little bit about the documentation.
If there is documentation. So if you go on GitHub, there's like a mailing list. I have to admit that as with many open source projects, it's not where it should be. So we're starting, and there's some, but it's not sufficient enough.
You know, there's like a reading on GitHub, and actually one major to-do we have is to actually, we have some.
Hey, stand up.
Oh, sorry. We do have some Sphinx documentation that we have checking the source code, but what major to do is actually get that to be rendered and hosted and stuff like that. Like all the good things we're inching our way towards those kind of things.
I was wondering, so you're playing back historical data as a purely open loop simulation. Are there issues with, you mentioned large trades before, with things where you actually need to simulate the market response to your work? Is that where you're
So that we are modeling in the way that if you place an order, then it's not going to be executed immediately and not at the price that you're seeing. And that's very much like in the real world. You see a price and you say, now I want to buy, and once that gets executed, the price might change, and then you actually not buy at that same price. And so we simulate that. We also simulate through the slippage model how the price impact would be. So that is happening behind the scenes without necessarily like looping back the data inside, but we are appropriately handling it.
And also the thing is, the slippage model is that's one of the things of, there's always open questions of like what is a right slippage model. So that's also something that you can kind of swap in your own slippage model. If you take those slippage models are inside of Zipline, and you can base off your own and instantiate it and just pop it into the backtester.
You make these slides available?
Yes. Yeah, I'll post that then on Twitter, I guess.
When you do a buy or sell call, can you specify limits so that you can say
orders. We currently, it's pretty high on our to-do list, but it's not currently up.
So and is there, when you do a buy, it's only one, can you specify many buys?
Yes. Yeah. Right. Actually, so at one go, like, like tomorrow I want to buy that amount, and then the day after that. Or?
Although if I'm doing like on a mid simulation, do I specify? You don't do limits, so you can't really do exactly what I want to do. But I want to specify. Let me throw out 500, Apple buy orders at different limit prices. See what happens.
Yeah. No, currently, yeah.
Right.
It's a much requested feature, but not yet.
Do you charge for those?
Once they're available, so the backtester will, with very high probability, like not the backtester, but just the web interface, and doing backtesting on that will, with exceedingly high likelihood, remain free and open.
Let's do 5 more minutes of
To a
questions.
treatise? Are you tied to a broker or trading house, or do you intend to do that, or how do you actually buy something?
So yeah, so essentially we'll be interfacing with interactive brokers, and then that's basically where your orders will be executed through.
And yeah, we're not married to one broker. That's one of our, that's a business question we are solving. Yes.
What part of it's gonna be open source? Will the engine be downloadable?
Sorry. Yeah.
Yeah, so Zipline, like everything I showed in the IRhythm notebook, that's all open source.
It's on GitHub, GitHub, Quantopia, and Zipline. You can quote it, download it.
Simulation engine downloadable?
Well, that is the simulation engine, right?
Yes, the answer is yes.
Yes. Like we have some closed source stuff that's like the parts that interact exactly that like create the data source that hooks up to our data. That's closed source, of course, because that's like the priority part. But the stuff that actually handles all those events, that is open source.
How did you clean up the data? What algorithm?
Well, we paid a data vendor, and then they provided things that also has they do some pre-cleaning. They provide things like splits and mergers and everything like that, and so we actually go back in time and adjust the price of the stock to account for that. So when you're running it through, you're getting that adjusted stock system.
How many equities?
Top of my head, I'm thinking about 8,000.
Other questions?
Yes.
On Quantopian, are you able to determine which of the trading algorithms are the most performant, and therefore can you use it as a platform for crowdsourcing the best trading algorithms?
So we're taking as far as like crowdsourcing, like we thought about having like contests or stuff like that, but people would have to opt into that. By default, like we're not going to be inspecting your algorithm. Like we're not trying to cull from people's and like crowdsource it privately. Some feature, some down the road, if people want to enter into some kind of like algorithm deathmatch, and whoever wins, like get something, or like get some funding or something like that. That may happen, but that's that's months, years down the road. Who knows?
I do think you make an important point, and that is also trust. And that is something which we're very aware of, that is very critical. I mean, the only thing we can really do is say that we are not looking at anyone's algorithms, and we're not. But certainly it's very important to us. Our users' privacy is very important to us. So everything you do is private, and certainly it will not be shared unless you explicitly say so, and it will not be like crowdsourced or anything if you don't opt in.
Let's take 2 more questions.
Yes?
In your illustration, you had some stuff that was operating on prices and the field prices. Is it easy right now to do a function of prices there, or it must only be prices?
You mean like just a transform of prices, like?
Like return or something, like average price.
Right. Yeah. I mean, the moving average would be doing that.
No, I mean for the price entry itself, not to be the price.
The price entry?
Some function, yeah. You had a field that said.
Oh, I see. Yes. So with the batch transform, you can actually do that. That you place new transforms of price inside, and then you can operate on those transform fields.
1 more.
Maybe.
Is it possible to specify the purchase order in terms of some percentage of capital rather than the actual contracts?
So in Zipline, we currently do not have that yet, but on the forums there is code people wrote, like a function that does that.
Like at that given moment, you'll have your current capital, and so you can do that. You can calculate that percentage by hand, but that might be some way we could enrich it, is to provide that automatically for you.
All right.
Okay, thank you.
Thank you.